Hi everyone, welcome to the video over binomial expansions. So first thing we're going to do is we're going to talk about expanding binomials and see if we can find any patterns. So if I have a plus b to the 0 power, remember any number to the 0 power is 1, so that's going to end up being just 1 altogether. Now if I have a plus b to the first power, that is going to be just a plus b. Now a plus b squared would be a plus b times a plus b. Okay, so then we would FOIL a times a, that would be a squared. A times b is plus ab. B times a is again plus ab, and b times b is plus b squared. So if I combine my like terms, I get a squared plus 2ab plus b squared. So that's what this expands to. A squared plus 2ab plus b squared. Please make sure that you do not think, let's write it up at the top, that a plus b squared like this, that does not mean that it's a squared plus b squared. Okay, so making sure we do that. Then if we look at a plus b to the third power, I've already have that out for you, but that would be a plus b times a plus b times a plus b. Okay, so we get a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, and then we have b to the fourth and b to the fifth. So take a second, look and see what patterns you see with all of these fully expanded, because our goal is to make this so we do not have to write it out like this every single time and multiply and multiply and multiply. Okay, so some things that I would like you to notice is that when it's to the first power, my outside two things have an exponent of 1. When it's to the second power, my outside two variables have an exponent of 2. When it's a power of 3, my outside exponents excuse me, have a power of 3. And when it's a 4, my outside has a 4. And when it's a 5, my outsides have a 5. Another thing to notice is that when it's squared, I'm going to start with a plus b squared. The second term is a 2. When it's cubed, the second term is a 3. When it's to the fourth power, the second term is a 4. And when it's to the fifth, the second term is a 5. Okay, so there's some patterns that go along with this, and that's going to lead us into Pascal's triangle. So Pascal's triangle is used to help us expand binomials so we don't have to do this long drawn-out process. Because if I did a plus b to the fifth power, I would have to multiply a plus b times itself 5 times. Okay, and that's going to be very tedious. Pascal's triangle is here to help us not have to do that. So Pascal's triangle starts with a 1, and then it goes 1, 1. It's always going to start with a 1 and end with a 1. The third row, or this would technically be the second row, so this is row 0. This would be row 1. Okay, it's 1, 1. Row 2 is going to be 1, 2, 1. So to get this 2 right here, we added this one and this one together. Okay, so the next row would be row 3. It would be 1. I add 1 and 2 and get 3. I add 2 and 1 and get 3, and it ends with a 1. Okay, are you seeing the pattern? Row 4. I have 1. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4, and it ends with a 1. So pause the video, see if you can do row 5 and row 6. Okay, so let's see. We did 1, 5, 10, 10, 5, and 1. Then we do 1, 6, 15, 20, 15, 6, 1. So how is this used? Well, if I have a plus b to the 0 power, then my answer is 1. If I have a plus b to the first power, my coefficients are going to be 1 and 1. Well, if we look back up here, they were 1 and 1. Then if I have a plus b to the second power, my coefficients are going to be 1, 2, 1. If I look, I had 1, 2, 1. A to the third power, or sorry, a plus b to the third power is 1, 3, 3, 1. Again, 1, 3, 3, 1. Okay, and so it keeps going for everything that we do. So I'm going to go ahead and fill in. We have a plus b to the fourth, a plus b to the fifth, a plus b to the sixth power. So how you can determine what row you use, you look at the second term. Okay, so we always start with row 0. Then row 1, we look at the second term. Row 2, when my exponent's a 2, the second term is going to be a 2. Row 3, when my exponent's a 3, my second term's a 3. When my exponent's a 4, my second number is a 4. When my exponent's a 5, my second number is a 5. When my exponent's a 6, my exponent's a 6. And this Pascal's triangle keeps extending until, however many you have. So if you have a power of 12, you would keep expanding, and those would be your coefficients. So now we're going to apply that into this example. So we have a plus b to the sixth power. So the coefficients we're going to use is this last row right here. So I'm going to go ahead and copy them down. That would be 1, 6, 15, 20, 15, 6, and 1. Those are the coefficients. Now, how we work with the variables is the first variable that you have, okay, or the first term that you have listed, you're going to start from big and work your way down to small for the exponents. So what I mean is you're going to start with a to the sixth and work your way down until you get to 0. A to the fifth, a to the fourth, a to the third, a squared, a to the first, and a to the 0 power. Then your second one, this one right here, you're going to work your way from small to big. So that's going to be b to the 0, b to the first, b to the second, b to the third, b to the fourth, b to the fifth, and b to the sixth power. Then all you're going to do is you're going to multiply these three columns together to get your final term. So we have 1 times a to the 6 times b to the 0. Remember, anything to the 0 power is 1. So 1 times a to the 6 times 1 is just a to the 6th power. Then I have 6 times a to the 5th times b to the 1st. That would be 6 a to the 5th b. Then I have 15 times a to the 4th times b squared. That would be 15 a to the 4th b to the 2nd. Then we have 20 times a cubed times b cubed. So that would be 20 a cubed b cubed. We have 15 times a squared times b to the 4th. We have 15 a squared b to the 4th. We have 6 times a to the 1st times b to the 5th. That would be 6 a b to the 5th. I have 1 times a to the 0. Remember, a to the 0 is 1. So it's 1 times b to the 6th, which is b to the 6th. So this fully expanded without having to multiply it all out would be a to the 6th plus 6a to the 5th b plus 15a to the 4th b squared plus 20a to the 3rd b to the 3rd plus 15a squared b to the 4th plus 6a b to the 5th plus b to the 6th power. So a couple patterns that you can notice is that my exponents always add up to be 6. So this one is 6, 5 and 1 is 6, 4 and 2 is 6, 3 and 3 is 6, 2 and 4 is 6, 1 and 5 is 6, and then 6. So every pair of exponents should add up to give you that exponent that's on the outside. Okay, so this is when it's basic and there's no coefficients in front of our variables. When we look at our next example, we have 2x plus 3y to the 5th power. So what's going to happen here is the exact same thing. We know that it's to the 5th power. Okay, so in Pascal's triangle, we're going to use the one right here. That would be row 5, where my second number is a 5. So those are my coefficient terms that we're going to use. So we have 1, 5, 10, 10, 5, 1. Now, we're going to take the first thing and work our way from big to small. So this entire 2x is going to the 5th power, 2x to the 4th power, 2x to the 3rd power, 2x to the 2nd, 2x to the 1st, and 2x to the 0 power. Now, we do need to simplify these, so that's what we're going to do. So 2x to the 5th power is 2 to the 5th power. So I'm going to write that above it, 2 to the 5th and x to the 5th. So we need to know what 2 to the 5th is. So if we go to our calculator and we do a new document, if you don't know it off the top of your head, you just do 2 to the 5th power and you get 32. So I get 32 x to the 5th power. Then 2 to the 4th power, you can do the same thing. That would be 16 x to the 4th. 2 to the 3rd is 8 x to the 3rd. 2 squared is 4 x squared. And 2 to the 1st is 2x. And 2x to the 0 is 1. So now we repeat that process with our second term. But remember, this one goes from small to big. So we start with 3y to the 0, 3y to the 1st, 3y to the 2nd, 3y to the 3rd, 3y to the 4th, and 3y to the 5th. And now we're going to go ahead and simplify them or write it out. So 3y to the 0 is 1. 3y to the 1st is just 3y. 3y to the 2nd is 9y to the 2nd. 3y to the 3rd is 27y to the 3rd. 3y to the 4th is 81y to the 4th. And 3y to the 5th is 243y to the 5th power. Okay, so to get our final term, we're going to multiply it all together. So 1 times 32 times 1 is 32. And then I would have an x to the 5th. So you're multiplying all the numbers together. Okay, 5 times 16 times 3 is 240. Again, you can be typing these into the calculator to write it out. And then I have an x to the 4th, y. Again, 4 and 1 add up to be 5. So your exponent should add up to be the same as the exponent on the outside right here. So now we have 10 times 8 times 9. That would be 720. X to the 3rd. Y to the 2nd. Then I multiply 10 times 4 times 27. That gives me 1080. X to the 2nd, y to the 3rd. Then I multiply 5 times 2 times 81. That gives me 810. X to the 1st, y to the 4th. Then lastly, I multiply 1 times 243. That gives me 243. Y to the 3rd power. I'm sorry, y to the 5th power. So again, each pair of exponents adds up, the exponents total add up to be 5. So my final answer for this would be 32 x to the 5th plus 240 x to the 4th, y, plus 720 x to the third y squared plus 1080 x squared y to the third plus 810 x y to the fourth, and lastly 243 y to the fifth power. And that would be your final answer, and that helps you from not having to multiply it out 5 different times. So if you have any questions over this first part, please write it down so you can ask me in class, and then make sure you check out the second part of this video where we talk about the binomial theorem.